So in this video clip, we discuss on the uses of FreeRTOS a little bit, and I will switch between the PowerPoint and the program. First, let's talk about how to create a simple task using a task create. First, you specify the function. Okay, the task function my task one here, and you use the task create my task one and name and priority. Okay, normally I wouldn't change some parameters here. I just specify the task function, and if I want to use the handle, I can put the task handler in here, or I can just say it as null in case I don't want to address it from another task. Okay, and you see that by using a task create, the task that use a task create is execute on core 0. Okay, so it's always on core 0 if you create it with a task create like this. And in the first example, we have two tasks that create with equal priority of 1, and the tasks just do some counting like this, and it counts for 10 loop. Okay, so it sends 10 messages, and then it ends when the task ends, and we call task delete to delete it from the memory. So this is the simple program that ends the task. If you want the task to run continuously, you don't have to put a task delete like this. So you just put the infinite loop in the task. Okay, but for this one, I just want it to execute for 10 loops only. And okay, so we see the program look like this, and upload this to the board. See that it's very fast, so maybe I can reset. You see that when the task has equal priority, you see the switch between two messages quite happen at the same rate. All right. So the message would switch with roughly equal priority, and the task will end at the same time. What is changed in example 2 is we reduce the priority of task 2 to 0. So now task 1 has higher priority than task 2. And you see the effect of this. Now, you see from this message that the message is mostly from task 1 first because it has highest priority. After that, the task 1 and then task 2 have then task 2 is able to execute. But when task 1 execute, it has high priority, so it consumes most of the CPU. Okay, you can do that. See that again. Right. If you want to pin some task to some specific core, you can do it. Just like in example 2, see here. You use a function extra create pinned to core, and you put the core number at the end. Okay, at the last argument, and the core is core the order core are 0 and 1. So if you put 1 in here, it means that you want your task to execute on core 1 and this task is on core 0. So now I have two tasks and that execute from two different core. Now you see from the message that even though I still put the same priority from the last example, and task 1 has priority 1, task 2 has priority 0, so task 2 has less priority, but it is executed on different core. Now task 2 is pinned to core 0. You see from the message that both tasks can produce message at the same rate. Okay, so uh, this task doesn't have to wait for task 1 anymore because it's executed on different core now. If you want to make a priority task, that means that the task is still at the consent period. You can use you can create the task using extra create or extra create into code, but in the task itself you do this. Okay, so you define a class wait time as type here type t, and then you call this function get tick count to this variable, and in the infinite loop you have at the end like this retard delay until and put the a class wait time like this, and this is the period that you want to wait. Okay, this means that in this case you have 20 millisecond period, and see how this works. And in the loop I echo the time period. Okay, so I measure the time period using milliseconds just like we did before, and then I have this period in the DT. So I put this DT to the cylinder to verify that the period is in this correct, and you see that it is. The period is 20 milliseconds as we specify in here. The task priority can be changed after you create the task by using VTAP priority set like this. And in this case, you have to specify the task handler for that task so that you can refer to it here. And this example 2.5, we change task priority after creation. Okay, from the output, we see that first the priority of task 1 is 1, task 2 is 0, so the task 1 is execute most of the time. But after 5 loop, we change the priority of task 1 to 0 and task 2 to 1. Now task 2 have higher priority, so it executes task 2 until the end. Then it execute the rest of tasks. If you want to suspend a task or resume and that you want the task to run again after you suspend it, you can use this with task suspend and with task resume and put the task handle to it. If you want to suspend all the tasks, you use with task suspend all. You don't have to put any argument here, as well as you have a task resume all. In example 2.6, we show how to create a queue. A queue is like a buffer. In this is first in first out buffer that can use to exchange data, to receive data from one end to the other, and we create the queue using a queue create like this, and the size of the queue. Here is the program. We have a consumer and producer. The producer just produce the data. Okay, put it in the queue. The customer receive the data, extract the data from the queue. So this is the picture how to use the producer and consumer and then the queue in this example. In the producer function, we generate the random uh, random number, and we say that if this variable is greater than 50, it is sent to the queue. So the rate varies, okay, depending on whether the generate value is exceeds 50 or not, and the consumer receive the data. So the number in the queue can grow and shrinks depending on the rate of the producer, right? Now, okay, you see that the number in the queue sometimes it increase, sometimes the number in the queue is zero. All right. Now it is to you see that the consumer can receive the value that the producer generate in the queue. Okay, so the queue is useful when the rate of the sender and receiver varies. If you send some data at the predictable rate, you may not want to bother using the queue like this. I think I can skip example 2.7 here. FreeRTOS allow you to create a timer task, but it is not different from a periodic task, so it has the same effect. So I prefer to use the periodic task to do what a timer task could do. But if you want to run this example, you see the message from the program look like this, and it works. Talk a little bit on the critical section protection. Critical section means some variable that you want to protect. Okay, maybe you have a global variable that's some task is written some value to it, but you want it to finish before the other task read the data. Otherwise, you have a collapse data. So you want to protect that part of the variables. That's called the critical section. There are some a few methods to do that. Okay, you can use macro and put the variable between the task center and the task exit. Okay, or you can stop all the tasks that access to that variable and resolve it when you finish. More advanced, you can use the semaphore or mutex. Okay, I have a simple example that generate a deadlock problem. This happens when uh, the task you see from task 1 here has mutex. Mutex just like a key. Okay, if you have a key to a loop. So this happens when task 1 has mutex 1 and task 2 has mutex 2. Okay, but this task want to get this mutex 1. Okay, so it hold the result. Task 1 hold the result and want to get the result from task 2. At the same time, task 2 hold it result and want to get the result from task 1. So that result in deadlock. In example to end, we see the deadlock when I press the reset button. Now you see that task 1 has to take 1 and want to get mutex 2, but to hold mutex 2. So it shows deadlock and the all tasks stop. Okay, it cannot execute anymore. This happen all the time and you pay reset. Okay, it happen to this the deadlock all the time.